Have you ever felt reality isn't quite as real as it seems? What if the universe you know is actually just lines of code in a cosmic computer? We think we're living in base reality, but what if we're not? What if we're just digital characters in some advanced civilization's video game? That's the simulation hypothesis. It's a mind-bending idea, but one that's gaining traction among some very smart people. Think about it. The more powerful our technology becomes, the more realistic our own simulations get. It's not a stretch to imagine a future civilization with the computing power to create a universe as complex as our own. Today, we're going to dive deep into these glitches, explore the science behind the simulation hypothesis, and ask ourselves, what does it really mean to be real? The simulation hypothesis sounds like something out of The Matrix, right? A world where everything you see, touch, and feel is just a sophisticated illusion. But it's not just science fiction. It's a serious philosophical proposition that has intrigued thinkers for ages. This idea has been kicking around philosophical circles for centuries, but it really gained traction in 2003 when Oxford philosopher Nick Bostrom formalized it. Bostrom's argument is simple. If future civilizations achieve a level of technological sophistication where they can create incredibly realistic simulations, then the number of simulated realities could vastly outnumber the one real universe. And if that's the case, statistically speaking, the odds are pretty good that we're not in the original, but in one of the countless simulations. Imagine living in a world where everything is a construct. Some very bright minds take this idea seriously. It's not just a fringe theory. Elon Musk, the guy who wants to colonize Mars, once said the odds we're not living in a simulation are billions to one, and I'll admit, even I find myself leaning towards the high probability camp when it comes to the simulation hypothesis. The more you look at the cosmos, the more plausible it seems. Think about the sheer improbability of the universe's existence, the finely tuned constants that allow for life. It's almost as if it were designed. The precision is mind-boggling. Artificial intelligence, virtual reality, quantum computing, we're creating increasingly complex simulated worlds all the time. Our own technology is inching us closer to creating our own simulations. The more we learn about the universe, the more its underlying mathematical framework seems to suggest a kind of elegance, a potential for intentional design. It's as if the universe itself is a grand, intricate code. Okay, so let's say, for the sake of argument, that we are living in a simulation. What would that even look like? How would we even begin to recognize it? And more importantly, could we find proof? Could we gather evidence that stands up to scrutiny? Well, just like any computer program, a simulation can have glitches. These glitches could be our clues. These would be anomalies, inconsistencies in the fabric of reality, moments where the code peeks through. They might be subtle or glaringly obvious. Think of it like playing a video game. In games, glitches are often a sign that something is not quite right. You might encounter a bug that causes your character to fall through the floor, or an object to suddenly duplicate itself. These are clear signs of errors in the programming. And in a simulated reality, they would manifest as glitches in the matrix. They could be visual, auditory, or even sensory anomalies. So what kind of glitches should we be looking for? What signs might indicate that our reality is not as solid as we think? Some people point to déjà vu, that eerie feeling of having already experienced something. It's like a momentary blip in the timeline. Then there's the Mandela effect, where large groups of people have shared memories of events that never actually happened. It's as if our collective memory has been tampered with. And what about the weirdness of quantum mechanics? The behavior of particles at the quantum level is baffling and seems to defy logic. The double slit experiment, for example, shows that particles behave differently when they're being observed. It's as if the act of observation itself changes reality. Some even speculate that paranormal phenomena like ghost sightings or unexplained disappearances could be glitches in the matrix. These events challenge our understanding of reality. These are just possibilities, but they highlight the fact that what we perceive as reality might be far more malleable, far more prone to error than we'd like to believe. Our senses might not be as reliable as we think. And if we can learn to identify these glitches, we might just be able to find the cracks in the simulation itself. Perhaps one day we could even hack reality. If we're going to find a real, undeniable glitch in the matrix, we need to know where to look. The universe is vast and complex, but certain areas hold more promise than others. One such area is the quantum level, the realm of atoms and subatomic particles, where the very fabric of reality seems to behave in the most unpredictable ways. It's here that the laws of physics as we know them start to break down, and the strangeness of quantum mechanics takes over, challenging our understanding of the universe. Think about quantum entanglement, where two particles are linked across vast distances, their fates intertwined in a way that seems to defy the limitations of space and time. This phenomenon alone could be a clue to deeper truths. Then there's the vastness of space itself, particularly those cosmic enigmas, black holes, which are some of the most mysterious objects in the universe. These gravitational behemoths warp space and time, creating conditions so extreme they might push a simulation to its breaking point, revealing hidden flaws or inconsistencies. Imagine looking for anomalies at the edge of a black hole's event horizon, or at the very edge of the observable universe where the known laws of physics might not apply. And speaking of underlying structures, what about the fundamental constants of the universe, the speed of light, the gravitational constant, and other values that seem to be finely tuned for the existence of life? The mass of an electron, for instance, these values are so precise that even a slight variation could make life as we know it impossible. But perhaps the most intriguing place to look for glitches might be closer to home, within our own consciousness, where the boundaries of reality are often blurred. Dreams, for example, often defy the rules of reality, presenting us with scenarios that seem impossible in the waking world. Could it be that during dreams our consciousness is less tethered to the simulation, free to explore hidden layers or access system logs that are normally off limits? This tantalizing possibility opens up a whole new realm of exploration. Now, before we all start questioning the fabric of reality and jumping off buildings hoping to fly, it's important to remember that not everyone buys into the simulation hypothesis. There are plenty of brilliant minds out there who think it's an interesting thought experiment, but ultimately unprovable and perhaps even unfalsifiable. One of the most vocal skeptics is physicist Michio Kaku. He argues that while the idea of a simulated universe is intriguing, it's inherently difficult, if not impossible, to test scientifically. Philosopher David Chalmers, while acknowledging the possibility of a simulated reality, raises another important point. Even if we are living in a simulation, does it really matter? These are valid points, and it's important to approach the simulation hypothesis with a healthy dose of skepticism. But even if we can't definitively prove or disprove the simulation hypothesis, the very act of asking the question, of exploring the possibilities, pushes us to think differently about the universe and our place in it. Let's say just for a moment that we do find definitive proof that we're living in a simulation. What then? What happens to our understanding of the universe, to our place in the cosmic order, to the very meaning of life itself? It's hard to overstate the impact such a discovery would have. It would be a paradigm shift on a scale that humanity has never seen before. Religion, philosophy, science, everything we thought we knew about reality would need to be re-evaluated. If our reality is just a simulation, what does that say about free will? About the choices we make? About the value of human life itself? Are we just lines of code following a pre-programmed script? And then there's the question of the simulators themselves. Who are they? Why did they create our simulation? Are they benevolent observers, or do they have more sinister intentions? Are we just lab rats in a cosmic experiment? These are unsettling questions, but they're also incredibly exciting. The discovery that we're living in a simulation wouldn't be the end of the story. It would be the beginning of a whole new chapter, one filled with endless possibilities for exploration and discovery. So, are we living in a simulation? The jury's still out on that one. But here's the thing about science. Sometimes the most important questions are the ones we can't definitively answer, at least not yet. The search for truth is often more valuable than the truth itself. The very act of questioning reality, of pushing the boundaries of our understanding, is what makes us human. And who knows, maybe that's the whole point. Maybe the simulation, if it exists, is designed to encourage us to ask these questions, to explore the unknown, to never stop searching for answers. If you like this video, please please like and subscribe. If you find a glitch in the matrix, let me know so we can share it with our community.